Okay, so we're looking at some solutions from lesson 2, similar triangles. So we're going to start right off. So our first question was 1a. Now, remember, we're singular triangles. Biggest advice you can get is when they give you something like this triangle ABC is similar to triangle DEF, it means this A is similar to the D, the B is similar to the E, and the C is similar to the F, which makes this very, very, very easy for us. So if we're looking at 1A, which angle is similar to which angle? Well, we can say angle A is similar to angle D. Angle B is similar to angle E. And angle C is similar to angle F. So that's a really important piece. The way they're organized tells you a lot about it. Okay, so the corresponding sides. That means this side is going to be similar to this side. So we have AB is similar to DE, and that means BC is similar to EF, and AC is similar to CF. So the ratios of the corresponding sides. So this is another easy one. All we need to do is just take all of the sides that we just developed and just turn them into ratios. So we can say if we have AB over BC, so those two, it's going to be similar to those two. Nice and easy. AB is similar to BC, which means that that is similar to DE over EF. And if we had something like BC over AC, well, that would be similar to EF over CF, and that pattern would continue. Okay? So that's exactly what we're doing with that. Number 2, just make a little box there so we don't get all confused. Number 2, so it says for each pair of similar triangles, find all of the missing measures. And remember, we have all of our information right there for us. It's nice and perfect. So we can actually go ahead and fill some of this stuff in. So X right here, which is 45, that's similar to D. So we'll put our 45 right there. And the missing measure is 47. This one, this 88, is actually the same 88 that's going to be there because those things are similar. The only things we need to figure out is what is this and what is this. But we know something. We know this 6 is similar to this 12. So we need to figure out what's our ratio. So what we're going to do is we're going to say, okay, our big, so 12 divided by 6 equals whatever this question mark is, that EF divided by what's over there, 5. So 12 divided by 6 is 2 equals EF over 5. So multiply both sides by 5, which means 10 is going to be equal to EF. So this is 10. So this triangle is actually twice as big. Look, 6 times 2 is 12, 5 times 2 is 10. What times 2 is 8? Well, we know this is going to be 4, but let's prove it to ourselves. So we're going to have something, so that's xy over 8 is going to be equal to 5 divided by 10. We can cross multiply here. Xy equals 8 times 5, which is 40, divided by 10 equals 4. So we were right. This is going to be a 4. Okay, same thing here. This angle is also going to be right there, so we have a 63 right there. This 32 is going to be over there, and this 85 is right there. So now all we need to do is figure out, okay, what are our sides all about here? And this one's a little bit trickier to get your mind wrapped around, because you might want to say, well, C is similar to E, and in that case, well, you'd be pretty right. They would be pretty similar, but unfortunately, they're not, because this is what I wanted to show you. You can easily make a mistake. Look how quickly you just think that 63 jumps right over there. It's not true. We need to slow down and we need to figure out what is actually happening here. Similar triangles are spooky like that. So this 85, we know that that's that missing angle right there. So right now we know if we redrew this triangle on this angle, this is how this would look. We have this 85 here, we have a 63 here, and we have a 32 here. So here's our 10, here's our 12, and here's our 6. Now, this is similar to that. This thing over here is a little bit rotated, a little bit sketchy. So let's use the one that we've redrawn, which is always good advice. So we need to figure out what is this side, we'll call it x, and what's that side, we'll call it y. So let's start off by figuring out what is x. So we have x over 10 equals 8 over 6. So we'll cross multiply again. X equals 8 times 10 over 6, which is 80 over 6, which will give me a value of about 13.3. So now if we want to do the same thing with y, we can say y over 12 equals 8 over 6. So we'll do the same thing, y over, we got to cross multiply. Y equals 8 times 12, which is 96 over 6, and that'll come out nice and even for me at 16. So those are our two missing values there. This one was 16, and this over here was 13.3. Okay, so how are we going to find the length of B and D? Well, we can do the same thing we've been doing this whole time here, right? So we need to find out the length of B and D. Well, we know things are similar already, so let's set up our ratios. 5.8 over 6.9, that's going to be our master ratio there, will be equal to B over 8.7. So we can use our cross multiplication, bring that up. So we get B equals 5.8 times 8.7, all divided by 6.9. So when we do that math on your calculator, like I always say, I recommend doing it all at once. It'll give you 7.31. Perfect. Now if we want to do D, we can do the exact same thing. So we'll take our 5.8 over 6.9 will be equal to now 2.1 over D. And when we do that, 5.8 times D equals 2.1 times 6.9 with that cross multiplication. So 2.1 times 6.9, it's about 14.5 equals 5.8 times D. So let's divide, let's break that D up. So divide by 5.8 and we get about, you're pretty close to 2.5. Okay. Now, part B. We should be good at this stuff because if you can do the first part, there's no reason you can't do this second part here. Okay, so this is just setting up a ratio. We're just trying to figure out H, and this one's actually even easier than the ones we can do it. So we're going to take our H divided by whatever is similar to it, which is the 1.8, equals 11.3 over 2.9. So H is going to be 11.3 times, because we can cross multiply, 1.8 divided by 2.9. And when we do that, you're going to have to put that all in your calculator at once, and I cannot do that off the top of my head here. 1.8 divided by 2.9. That gives me a height of about 7.01. Okay, good stuff. So the next ratio we want to figure out is what is the length of this marsh, this x in here. And we actually have all the information we need. So let's set up a ratio. So we have x divided by whatever it is similar to, which is 16.2, equals, and then we need to figure out, okay, well, what's going on here? So this x is in this triangle, so we have 18.6 divided by 3.6. And now we will cross multiply up. X equals 18.6 times 16.2, all divided by 3.6. And we'll put that into our calculator. 16.2 divided by 3.6, and that gives me 83.7. Okay, next we want to figure out how tall this tree is. This is going to be our x value here. So we'll take x divided by, what is that similar to? It's similar to 2. And then we have this 20, which is going to be similar to our 4. So we'll take 20 divided by 4, cross multiply it up. When we do that, we get x equals 20 times 2, which is 40, divided by 4, so our tree is going to be 10. So we have two things. We have our 10-foot ladder, and it says it reaches 8 feet up the wall. Oh, sorry, I got that all backwards. We have a 10-foot ladder and we have an 18-foot ladder. So here's our 10-foot ladder, here's our 18-foot ladder, and now it says the 10-foot ladder reaches 8 feet up the wall. We want to know, what is this distance over here? And this might be a little tricky to understand just by these diagrams here, so let's redraw them. So we have our 18-foot ladder here, and we want to figure out what's the height that way. And then we have our 10-foot ladder, and we know the height, it goes 8 up the wall. So let's figure out what is our x. So we have set up our ratios. X, what is it similar to? It's similar to the 8 equals our 18 divided by our 10. Okay, so let's cross multiply that up. We get x equals our 18 times 8 all divided by 10. So 18 times 8 divided by 10 is going to give me 14.4. And that is it for this lesson and the solutions. Make sure you are doing your quizzes. See you later.